So in the last lecture we saw how to differentiate exponential functions. So we learned there are now a lot of functions we want to differentiate. But there are still a few that we have not seen how to deal with. So some examples of ones that we don't know how to work with are the natural log of x, or any log, the inverse trig functions like arcsine of x, and arctan of x. So what do all these functions have in common? Well, they're all inverse functions of things that we do know how to differentiate. So we know how to differentiate e to the x, which is the inverse function of log. We know how to differentiate sine of x, and that's the inverse of arcsine. We know how to differentiate tangent of x. So if we somehow know how to differentiate inverse functions in terms of the original function, then we could handle all of these things. So the topic for this video is going to be derivatives of inverse functions. So let's first look at logs. So the first thing to notice as a trick is that we know because e to the x and log of x are inverse functions, e to the log of x is equal to x. So this is our starting point. And this is basically just because the function and the inverse function cancel each other out. So you're familiar with, if you have an equation like this, you can square both sides, you could take the square root of both sides, you could take the log of both sides. Another thing we're allowed to do if two functions are equal is take the derivative of both sides, and we still have an equality. So we can write that the derivative of e to the ln of x is equal to the derivative of x. How does this help us? Well, we want to find the derivative of log of x ideally, but let's see if we can differentiate this thing on the left-hand side. So by the chain rule, we take the derivative of the outside function. Derivative of e to the x is just e to the x. So we get e to the ln of x. But then remember, we have to multiply also by the derivative of the function inside, which in this case is the log of x. We don't know that derivative, so I'm just going to leave it as derivative of log of x. That's something that who knows what it is at the moment. And the derivative of the right-hand side is 1. Now, e to the log of x, remember, is equal to x, so we can simplify this a little bit to just say that x times the derivative of log of x is equal to 1. So now we have an equation here involving the derivative of log of x. We can solve for that derivative and get that the derivative of log of x is equal to 1 divided by x. So even though we weren't able to get at the derivative of log of x directly, by using this trick of writing that the function applied to the inverse function is just equal to x, and then differentiating both sides of the equation and applying rules that we do know, we're able to solve for what the derivative of log of x is. And you could do a similar procedure for any base logarithm. So the derivative of log base b of x is going to be equal to 1 over log of b times x. Okay, so that's how you differentiate log functions. Now let's look at inverse trig functions. So if you look up here, we're going to use the same trick as what we did for log. We started off by saying the function applied to the inverse function is equal to x. So let's suppose we want to find the derivative, for example, of arc cosine of x. Well, we know that arc cosine of x I don't need that parentheses, is equal to, sorry, I know why I want to write that parentheses, is because we have to say cosine of arc cosine of x is equal to x. So that's our starting position, analogous to this first equation here. Then we can take the derivative of both sides of that equation, just like we did before. So we have cosine of arc cosine of x is equal to the derivative of x. So we know that the derivative of x is equal to 1. And for a derivative of cosine of arc cosine, we have to use the chain rule. Derivative of cosine gives us negative sine of arc cosine of x. And then we have to multiply by the derivative of the function on the inside, which is exactly what we wanted to figure out, the derivative of arc cosine of x. We know that this entire thing has to be equal to 1. So if we rearrange this, we get that the derivative of arc cosine of x is going to be equal to negative 1 over sine of arc cosine of x. Okay, so we have sine of arc cosine. We saw in a previous lecture that sometimes that sort of thing can be simplified. So suppose that arc cosine of x is equal to some angle theta. We don't know what theta is, but we do know that if we take the cosine of both sides, it must be that cosine theta is equal to x. So if we draw ourselves a triangle, and this is theta here, we know the hypotenuse has to be equal to x, so the adjacent side is x, the hypotenuse is 1, then by the Pythagorean theorem, we know that this side must be square root 1 minus x squared. So that tells us that sine of theta is equal to opposite, which is 1 minus x squared, divided by adjacent, which is 1. So that's the same as square root 1 minus x squared. And we wanted to find sine of theta, which is sine of arc cosine of theta. So we can now go back up here and write that this is 1 over square root 1 minus x squared. So that's the derivative of arc cosine. Similarly, we can find the derivative of arc sine is equal to 1 over square root 1 minus x squared, now with a positive sign. And we can find that the derivative of arctangent of x is equal to 1 over 1 plus x squared. And if you were really interested, you could find derivatives of other inverse trig functions as well, but these are the ones that you most commonly see. Alright, so we've seen now how to find the derivatives of logs and arcsines and arc cosine, and all of this is sort of examples of a more general rule for derivatives, which is the derivative of just the inverse of some function. And to derive what the formula looks like, we're going to use the same procedure as before. So we know it's always true that f applied to the inverse function has to be equal to x. So just like we did when we had the specific example where f was log or f was cosine, we can take the derivative of both sides and by the chain rule we get the f prime of f inverse of x times the derivative of the inside function, which is the derivative of f inverse, is equal to 1. And that tells us the derivative of the inverse function is equal to 1 over f prime of f inverse of x. So this is the general formula for the derivative of an inverse function. So let me do an example of how we would use this. So let's suppose we have some values for x, f of x, and f prime of x that are given to us. So let's see. we'll have values 1 through 5, and we're told values of f of x and f prime of x. So let's suppose we want to find the derivative of f inverse of x at x equals 5. Well, we can use the formula that we just derived. The derivative of f inverse of x should be equal to 1 over f prime of f inverse of x. And so that means, in particular, that f inverse prime of 5 is equal to 1 over f prime of f inverse of 5. So if we want to find this value, we first have to find f inverse of 5. So f inverse of 5, well, if we look at what value of x makes f of x equal to 5, well, that value is equal to 3 based on this table here. So f inverse of 5 is equal to 3. So therefore, f inverse prime of 5, if we just plug this in, is 1 over f prime of 3. Then if we look at our table here, f prime of 3 was equal to 1. So we get 1 for our final answer. So that's an example of how you can use this formula up here for the derivative of an inverse function to calculate the derivative of the inverse function, knowing only information about the derivative of the original function.